Good morning everybody. Welcome to another day of the Matrix Conference. You've made it so far. Good job on getting here this morning. Welcome to Lab 4. Today we're going to have a talk on Simplified sliding sink. I know you're all very excited to hear about it. So please give a very warm welcome to our speaker, Ivan Enderlin.
Hi, do you hear me? Okay, good. So yeah, I'm Ivan, and I'm here to talk about sliding sink. So at the beginning, we have metrics. Hope you know it. It's about communication, and so communication happens inside rooms, and rooms are grouped in a room list, and each room contains timeline composed of events. So that's the basics. And our goal is to sync the rooms with all events as fast as possible, including all possible cases like E to E and so on. So join me for a hike. So sliding sync has been mostly driven by room list features. So here we have a room list, and we see like the rooms can be filtered or searched. They are sorted also by recency or by name. How do we sort encrypted rooms? And also we have some markers attached to room, like notification, mentions. And for a room, you see like a name. If the room has no name, we have to compute a name based on heroes. There is also an avatar and also a preview, so what we call latest events. So are we able to have this latest event? Are we able to decrypt it if we need to? All kinds of questions. So sliding sync in a nutshell. This is an iterative sync mechanism. So we don't load everything since last time you have opened the app. We load the rooms page by page. And rooms are sorted. And again, how do we sort stuff if they are encrypted on the server? This is really complex, actually not possible. And for a room list, we want to load some events. So are we able, how many events do we want to load? Are we able to load more? For example, if you scroll and then the user stops to scroll, the user is likely to open a room he has in front of its eyes. So maybe it is time to load more events. So this mechanism has to be really flexible. So enter MSC 3575, named sliding sync, published at the end of 2021. We didn't want to experiment inside Synapse directly, so a proxy has been created, the famous sliding sync proxy, with the first implementation inside the REST SDK, and 2 implementation in apps, Elementix, iOS, and Android. So what can go wrong? 1 new server, 1 new client, 2 new apps, 1 new sync mechanism. It was not cool. So this is debugging cycle. So we were testing stuff and we saw bugs. So where is the bug coming from? Proxies, SDK, Elementix, no idea. Is it a bug? Is it a missing feature? And repeat this cycle over and over again. And so what were we testing? So first accuracy. So did all the data work correct? And can we select more data when we need to, or less data? For example, if the network is a bit crappy, can we reduce the amount of data we would like to load? Network performances, so bandwidth, we were looking at request and response sizes. How fast is it to recover from an error because networks, and so this is pretty unstable, and stuff like that. So we have 3 characters now. So the proxy, the REST SDK, which provide a sliding sync API, and on top of it, we have 3 new APIs, the room list service, encryption sync, and the notification client. And Elementix, a brand new app that requires sliding sync. So it doesn't work with Sync v2, for example. It is designed to work with sliding sync. So sliding sync principles. I don't know if you're all familiar with it, so let's start with the basic principles. So the server maintains 1 or more lists of rooms, depending on the request. A list of rooms is sorted and filtered, and a list is updated by some event. So maybe you have a room somewhere in your list, and you are interested by some events, so the room is going to bump to the top of the list. But you are not interested by all events, so you have to filter those events. And each room of a list has a maximum number of events. So this is what we call the timeline limit. So do we want to load 1 event, 20 events, or more? So this is flexible. And the client requests a slice of a list. But before showing how it works, sliding sync has a notion of sessions. So this is defined, it relies on the post query parameter. So this is like for position. So first request, the client has no position. So the server understands that as, okay, I have to start a new session. So I have to create those lists of rooms, collect all the rooms, and so on. It can be costly. And then the server responds with a position, in this case, position A. This value is totally opaque for the client. So the client has to resend it for the next request. So next request, position A. And the server is, oh, I know this position. So the session is kept alive, and I'm going to maintain this session for you. And then the server responds with maybe the same position or another one. This is opaque, we don't know. But if the client sends a request with an unknown position, the server will say, okay, the position is unknown or too old maybe, so I'm going to close the session. Now, request and response. So the endpoint is matrix/client unstable org.matrix.msc3575/sync. And we see our position here. So the payload is, we have a connection ID, transaction ID, list, room subscription, and unsubscribed room, and extension. So I'm going to details on only the list part. So a list has a name, here my list name, and each list has a range, sort parameter, like here recency and name, the bump event times, so which type is going to bump a room, the timeline limits, and some filters. And for the response, so we see our famous position, the transaction ID from the request, list, rooms, and extension. So let's focus on the list. So we see my list name again, and for each list we have the number of rooms that are part of this list. So here 42, and some ops. I'm going to detail that in a minute. So this is a sync operation. And the rooms is a flat list of all the rooms aggregated from all the list. And for each room we have like name, avatar, required state, timeline, some tokens, and so on. So let's see in action. I don't have a demo, but this is like a slide demo. So we have a set of rooms unsorted. This is the lead on the server. And client is doing a first request. So we have no position, and the range, so this is 0 to 4 included, so 5 rooms. So we want 5 rooms. So the server starts, oh, this is a new session. So it starts by ordering and preparing the list. And then, okay, I'm going to return the top 5 rooms. And they are marked as sent. No update. So just they have been consumed. So request number 2, now we have a position, for example, and the range is the same. So what is going to be the result? Nothing. Like rooms has been consumed already. So we have to increase the range. So request number 3, the range now asks for 10 rooms. So the server selects 10 rooms, only 5 have an update, let's return 5. And now some stuff happens on the federation, we have new events, so the rooms are going to receive some updates, maybe they're going to be sorted again or filtered again, and the client request is doing another request, arranged for 10 rooms, there is only 2 updates, return 2. So this is how sliding sync works, basically. And inside the SDK, we have concurrent sliding sync loops. We have 2 sync loops, one for the room list service, and one for encryption sync. Notice that they have a different connection ID. So connection ID is a way to represent, it's like a pair of the session and the connection ID. It helps to have multiple sessions at the same time on the server. And push notification. So notification line also use a sliding sync loop. And this mechanism so you don't have to understand this slide exactly. This is just to illustrate how flexible this mechanism is. So the room list has an inner state machine. And so when you start the app for the first time, the room list is in the init state. And so we are going to load only 20 rooms. and then stuff happen. We are in the setting up state, then running state, and now we can load in the background more and more rooms. So the range now has a batch of 100, and we are loading 20, 100, 200, 300, 400 rooms in the background. And when we have an error, we can recover, so we enter the recovering state, and then we jump back to a small list, and then we increase again. So this is pretty flexible. And those client ranges API are not part of sliding thing. It is only client specific. So we have selective range and growing range. And so, like I said, the selective range, this is a constant range. So if we say size 20 for each request, we're going to request 20 rooms. And for growing range, if we have a batch size of 100 for each request, we are going to add batch size. So taking a break. Is sliding sync working? Yes, it is. It's working. It's fast, like really fast. But we see some efficient pattern emerging. And the proxy is really costly to run. And there is bugs, like nasty, complex bugs in it. We were experimenting with the proxy, so the code has changed a lot, tried some features, stopped it, etc. So the idea is maybe it's time to simplify sliding sync. So this is our objective, got to the top. So first, when we were filtering the room list, we had to do a request and response round trip. This is not instant, it depends on the network. What if you are offline? So filtering must happen client side, not server side. So from the MSC, we are removing a lot of filters, and we only keep is invite and not room times. And so inside the SDK, it looks like this. Like we have room list.entries, and then we apply filters. This is really customizable. So here we want all filters to apply. So unread, favorite, and fuzzy match room name with matco, like matrix conference, for example. This is an example. And same for sorting operations. So sorting happens on the server side via the famous ops I told you. And so the server was maintaining the list and was only sending the diffs. And so we had 4 operations: sync or invalidate to insert or remove multiple rooms, and insert or delete for single room. The design is nice, but in reality, this is really complex. And for the server, it is extremely complex to maintain the state, especially in the session and so on. And also, this is incorrect by nature. Like, how do you sort encrypted rooms? This is not possible. You have no idea what's inside. And same for the name. Like, if a room has no name, you have to compute a name to calculate one. So you use room heroes, for example. And depending on the client, you have different localization, the comma, the and separator, and so on. So the server was pre-calculating something like that, but it was not taking into account localization of the device. So let's remove those and move sorting operation directly client side. And so in the SDK, it looks like this. We have like a lexicographic sorter and recency and name, and ta-da, it works. All the removals, so BUP and event type are now hard-coded on server side. It was very complex to make it dynamic. Delta token was part of the MSC, but was never implemented. Slow get all rooms could be replaced by growing range, and so on. So we have removed a lot of stuff. And it marks the end of the experiment. So the proxy was nice to hack and try stuff, but at this point we know exactly what we want. Sliding sync is more stable, so it's time to deprecate the proxy. It's been announced yesterday by Matthew, so the proxy is going to be deprecated in 1 month. And so enter MSC 4186, named Simplified Sliding Sync. The endpoint is a bit different. This is simplified _ MSC. And this is implemented inside Synapse already. So it's part of the 1.114, if I'm not mistaken, release. And we are migrating everyone from the proxy to Synapse on matrix.org. And the REST SDK speak both MSC for a couple of months. So Elementix, for example, is going to automatically migrate users, and the SDK provides an API to detect whether your home server is using the proxy or support Synapse with a simplified sliding sync. And so you can use this API to migrate users to someone's taking a picture. Okay. But there is more simplification. So sliding sync has non-negligible cost on the server side. And so we are also extracting some use of sliding sync into new endpoints. So we have a new /sync to /sync/e to EE endpoints, and we are also improving /context. Why are we doing that? So that in the short future, we'll have the room list only using sliding sync. Encryption sync is going to use /sync/e to EE, and notification will only use /context. So this is going to be much simpler, architecturally speaking. So we did it. We had a submit. Nice view. Everything happened in the SDK live. So this is like a bonus slide. And we are relying a lot on reactive programming. And so inside the SDK, we have a single observable map, which is a source of truth. It stores all the room we have. And we can subscribe to it. And when you subscribe to something which is observable, then you get a stream of stuff, of updates that happens to this map. And the beauty of it is that we can filter this stream, and we get another stream, and we can sort this stream, and we have another stream, and we can limit the stream, and we have another stream. And so this pattern is very nice because this is really flexible. This is all async. So the app like iOS or Kotlin or anything like Swift and event bindings doesn't have to ask the application, do you have an update, do you have an update? It happens asynchronously. So this is extremely lazy and performant. And this is really complex also to implement, so I have started to write a series on my blog if you want to learn more. So thanks for your attention. So as a conclusion, 2MSC 3575. We keep this MSC alive for the moment because maybe we can reuse it for something else. This is implemented inside the proxy. New MSC 4186, which is the final proposal already implemented inside Synapse, and this is our feature. And the SDK support both for the moment, and all applications relying on the SDK will have this for free. So thanks.
Thank you so much. All right, we have some time for questions. Please raise your hand, and if you're watching the stream online, please ask them in the Matrix room. All right.
You said there will be no impact on the performance of the backend. Does this mean no, like zero? So if I migrate to sliding sync, I won't have any load impacts on my database?
I did not talk about performance on server side, but
okay.
So sliding sync has a non-negligible cost for sure. This is new sync mechanism, but inside Synapse this is native, so it is way smaller than what we had with the proxy.
Okay.
You don't have to duplicate the data and so on. So it just reuses the same data in the same database.
Is there any known number of load impact on backend when migrating to sliding sync?
I don't have those numbers, but it was really difficult to migrate to keep the proxy alive for matrix.org. But with Synapse is not an issue. That's what I know. So yeah, the impact might be minimal. I don't know. I'm not maintaining a home server with real users, so I don't know.
Maybe I can speak a little bit about it.
Yeah.
So Sync v2 was actually very expensive to serve on the server side, and so I think you'll actually discover that sliding sync is a lighter way to serve than the previous version of sync.
No, we didn't.
I don't have numbers, I'm afraid.
Sliding sync because of the load, so I'm waiting for the simplified sliding sync, and hope that there will be no. Hope that there will be really no major impact on the backend. So
We have been very careful for that. So I said we, but I did not work on the backend side, only the client side. But yeah, it should not impact your home server. Yeah.
Okay, thank you very much.
Hi, thanks for the nice summary of the simplified sliding sync. I'm excited to use it from the client side. You mentioned that element X, quote, automagically can determine which one to use. is that just using a feature of the upcoming, or maybe a already released version of the REST SDK?
Yeah.
Or is it doing something else?
Exactly. Thanks for asking. So yeah, this is it's relying on an API the SDK provides to discover which sliding sync version is accessible on the server. So either the proxy, which is not the home servers, or either the proxy by using the well-known endpoint, or by looking at some features on /versions, for example.
Okay, so all the other clients using the SDK can also benefit from this detection. Okay.
And is going to use this API to know what to do. So the SDK doesn't migrate user for itself. It just gives all information to the app, and the app decides what to do with that.
Okay, thanks.
Thank you for the talk. What's the state of SSS on web, and how will the migration be there?
On SSS, on the web?
Yeah, on Element Web.
I have no idea.
Yeah,
So
no.
I have discovered yesterday that it was apparently working on the beta version. I know they have worked hard to make it work for today, for yesterday, for the conference. But I don't know exactly. Yeah.
But soon, I guess.
Yeah, pretty soon. Soon-ish, yeah.
Yeah, it's working as a prototype, but there's no timeline as of yet.
You mentioned that the server does not compute the order of the rooms. So if I have a client wants to update the room list, I have to fetch all the rooms to get all the updates again. So the sliding sync doesn't help me in that case, or does it?
So it sorts the rooms somehow, but by recency. So this is the best effort. It tries to sort the room by recency without taking account buffer types or stuff like that. So it tries to do, this is the best effort. Otherwise, we could see like rooms moving a lot when we start syncing. So the idea is maybe we're not interested by some event that could bump the rooms, but in practice, it works well like this.
Partly, I have this question for web. Is there any vision on when other languages will be supported? Because at the moment we can only use sliding sync in Rust, as far as I'm aware.
Yeah, and we have bindings, official binding to Swift and Kotlin. Our crypto stack is tested with numerous ways. One of them is Complement Crypto, and Complement Crypto is using the SDK with bindings for Go, so the Go language. We don't support other bindings officially, and I don't know if there is other SDK using sliding sync yet. I'm not aware of that. But now it's possible because sliding sync is simple now. So.
There's an issue, for example, with the iOS app that doesn't correctly display the notification unread number. Do you think that this implementation will address that? Because as I observe the old iOS app, because we're currently using that, so we kind of interested in it.
I don't know what's the problem with your notification. Maybe we didn't have the to device 7 to decrypt the notification, or I don't know.
Yeah.
For sure, it has helped to gather most data when we wanted to. Before it was complex, like when we were receiving a notification, especially on iOS, we had a very small period of time before the process was killed. And so running Sync v2 was taking too much time to gather all information to decrypt notification or not. With sliding sync, we are now able to fetch only the data we need. And so it's faster to decrypt and to display notification. So it may solve problem you have.
Okay, so currently the notification display correctly using this?
Yeah, absolutely.
Okay,
yeah,
that's
yeah.
good. Yeah.
Also, I'm using sliding sync on simplified sliding sync on my phone since 3 months, and
okay.
it works smoothly. So yeah.
Okay, thank you.
All right, we're going to take a quick question from the room. Right, No Way asks, what plans do you have for the future of sliding sync? Is there room for improvement still?
Yeah, absolutely. So this slide, like you would like to extract some other patterns from sliding sync to make it more and more simple. And also, as soon as we have deprecated the proxy entirely and removed support from the SDK, we would like to revisit a bit how the range API works. I'm not going to into details because this is very complex, but yeah, we would like to have a thinner grain I'm looking at you, but for the chat again. Yeah, so maybe revisit the range API a bit. but the overall architecture is not going to change a lot, and every change now are going to happen as a new MSC. So we're not updating the same MSC again.
Hi. If you only receive incremental responses via sliding sync, that requires the client to cache all the rest of the state probably, so you can update the whole state. And I know that the Element X clients are not really good at, for example, offline caching right now. So will that, once that comes, will that even increase the performance of sliding sync? So the client only really needs to incrementally update what it knows the current state to be?
So it depends on the user. So first, yeah, Element X doesn't cache a lot. The SDK in general does not cache all the events for the moment. So they are cached in memory, but as soon as you kill the app, they're gone. And so yeah, we have to request everything every time, but we're not reloading all events for all rooms, only the events we need. And so this is particularly useful for users with a lot of rooms, or especially with very active rooms. It's fine to have gap in the data now, and we can fill the gap when we need to. So it might be costly somehow if we don't cache on the client because we have to re-request the same data again and again. This is part of my job for the next 2 or 3 months, is to have persistent storage inside the SDK. We are almost done for that. Having the persistent storage is easy. This is not the complex stuff. The complex stuff is how to reconcile, like if we have received an event from the sink and we backpaginate, we may receive the same event again because this is not the same order, sink ordering versus topological ordering. And so which event do we need to keep? Which one to filter out? This is the question. And yeah, I was pretty focused on that, but after, yeah, persistent storage in the event cache, and then we are going to save a lot of data from the server.
Very exciting.
Thanks.
Maybe one more thing about the encrypted rooms. Like, how does it work when you log in? Like, normally you retrieve the full backup, and then all your keys need to be processed, kind of, and then you see those messages. Is it like included here that you just retrieve keys for the specific messages in the rooms that you get on the first sliding sync calls, or do you still retrieve all the keys and it's still kind of slow to see all the messages?
I don't know all the details about encryption, but maybe you can answer this. So I know we are downloading the backup. We are also downloading 2 device events. We need to decrypt the events. But we don't re-download everything every time, I'm not sure. Yeah.
It's on demand.
Yeah, this is on demand, yeah, exactly.
Will it be maybe a problem if I mix Element X clients and older clients on a newer home server when I migrate to sliding sync? Or do I have to migrate all my clients at one?
No, so you can migrate one client at a time. You can migrate one client at a time.
Okay.
You don't need to migrate all the clients. Yeah.
Okay, I can have 10,000 older one and 10,000 newer ones.
Yeah.
Okay, thank you.
Yeah. Yeah, that's also the beauty of this. So the SDK, if you use the SDK, keep some information in a cache, like the slush version to get the unstable features from Synapse. They are kept for 7 days. So if your users are using the app slowly, not slowly, they are using the app, but they are going to migrate one after the other, not all at the same time, which is pretty helpful to mitigate the impact on the home server. Yeah.
Do we have any more questions? Yeah, at the front. Time for 1 or 2 more.
So obviously your issue with encrypted messages is you can't search, and you mentioned earlier that it's fine to have a gap between your sync calls. How do you then solve the searching issue?
So we are not able to search anything for the moment, but so this is part of the event cache API. Benjamin Bouvier yesterday told about that. So the idea is, because of sliding sync, we can sync whatever we want, any slice of data we want. So the idea is you load only your latest event, and if there is a gap when you enter a room, we are going to fetch backwards to sync all the missing piece. in the background, so transparently. And so that way, and as soon as we have persistent storage inside the event cache, we'll be able to store all events and magically no gap anymore. We have to find the correct balance. Like if you enter a room like Matrix HQ and you didn't enter the room for like 1 year, you don't want to load the backlog for 1 year. So we have to find some heuristic about that. And as soon as we have event decrypted inside the event cache persistent storage, we can search for events. So this is a funny features to add. And when we are here, it's easy.
All right, I think that's all the time we have. Please give another round of applause to Ivan.